Well, thank you very much for the introduction. Good afternoon, dear automotive wiring harness community. Let me first introduce myself a little bit. My name is Jürgen Reinhardt. Well, I've been working for the automotive wiring harness and component industry for more than 40 years, and since 5 years now, I'm as a technical advisor for Tersonic in Switzerland. So basically, well, I'm really delighted to have the opportunity today to introduce you to the highly interesting and important topic of the fundamentals of automated production for automotive wiring harnesses. I would like to report briefly on this today and, building on this foundation, highlight how just important our joint work on the development of the standard 72 or 36 is today. Automation in automotive harnesses is nothing new. As in the early 80s, 1990s, major projects were carried out. For example, in the automotive and appliance industry, we had in Citroën and Renault, I remember very well, produced complete harnesses mixing many different technologies, IDC, crimp technology, old and new terminals, and so on. Volkswagen produced complex harnesses were in their own plants. I will come up to later on this item. Audi had used IDC technology in the instrument clusters. Interesting is in the home appliance industry, the standardization of components was achieved at a very early stage in coordination with the appropriate manufacturing technology. In this case of Rust X connection. X stands for the different pitches between the terminals, so there are different sizes. Significant is this connector system already met many of today's automotive automation requirements. Various manufacturers offer semi-automatic and fully automatic processing machines, which connection systems from different suppliers can be used. Well, the primary motivation at that time was cost reduction in the manufacturer's in-house production. So let's have a short look on the project I mentioned before. In this project, we were focused on coordinating the wiring structure with the OEM, defining the component design, the contact parts, and the connector housings for optimal processing. Product optimization were also considered and implemented. For instance, eliminating cable cutters resulted in a process time reduction of almost 20%. This led to significant cost savings in both the investment and the subsequent production. The final test specifications, taping, marking of the produced harnesses were agreed and implemented. For us that time, I was the project leader at that time, the coordination was relatively easy. The contact parts, connector housings, machinery came from our own company, and we knew the customer from years of collaboration. But anyway, coordination between development, production planning, plant planning, and logistic and procurement was complex as the machines were installed in the OEM's plants themselves. Even back then, issues like purchased components such as cable quality, the properties of adhesive tapes, and the marking of the harness, including the test documentation, were already apparent that days, had to be considered all the time. Now, to be honest, what happened with all these efforts? There were a large number of different automation projects that time internationally that were undermined by the relocation of production to the low-cost countries. For Central European manufacturers, that meant Eastern Europe and North Africa. In the US, Mexico with its maquiladoras. But anyway, what is the situation now? How goes standardization on? Standardization is nothing new. Looking back, it becomes clear just how important our standardization work is within the collaborative framework involving OEM departments, harness manufacturers, component suppliers, and the machine manufacturers. These stakeholders have been working for many years to agree on standards. Many standards governing the requirements and approval conditions, for example, for contact technology, crimping, welding, and so on. The interchangeability or compatibility for components, that means contact parts from different manufacturers in standard cavities and so on, were developed in various working groups like Arbeitskreisterminal, Bayern Innovativ, US cars, and so on, either between the OEMs and the companies or between the companies themselves. This all led to guidelines, standards, and various norms. Unfortunately, this was restricted by the BKA, by the German Cartel Office. That was a very unlucky situation. That is why we at SLS now work in close consultation with legal counsel to prevent such issues from arising in our project here. The harness. The harness is one of the, let's say, most sophisticated and complex products in our cars. Many different aspects have to be considered and has to be taken into account. We start with the harness itself. What type of harness are we working on? We have high voltage cables which have a growing potential due to electrical cars within with high technical requirements and detail. We have the low volt cables with high potential and at the same time the greatest challenge for automation due to the high volumes and the high complexity. Interesting are the high frequency cables. Due to the high demand and simple cable harness structures, various customized automation solutions already existing. Well, we are not only taking on this detail, but we have a lot of more details we are taking account into the norm. We have the types of electrical of lines in the car. On the one side, we have the electrical lines, standard cables, shielded cables, and so on. And also, we had to set up norms and standards for non-electrical lines like wiper water washer, vacuum pipes, and so on. Next step were the components that are content of the harness. There are a lot of subcomponents like tapes, tubes, cable ducts, clips, cable ties, grommets, wires, and so on. And the system components, they are terminals, connectors, yes, and splices. You may ask why splices are mentioned here. We decided to settle splices as connector due to the digital description. But after all, in order to produce a harness, we need a lot of production processes. And here is really a large range to see, like crimping, welding, heat shrinking, taping, clip application, stripping, terminal insertion, foaming, and so on. That led finally to harnesses where we have also various design requirements. For example, the cable length in special applications. Significant point is the overall connection structure, the complexity of the harness that has to be automated, and also the number of wires defined in some sub-harnesses. Well, now after all, we have the development process that is a significant point of our norm. Normally, the wiring harness development process starts with it begins with the OEM's scheme plan, where we describe normally terminals, connectors, wires, and cables. And we are aware of the necessary application technology that is used. That the next step is the really extensive and detailed drawings produced by the wiring harness developers and manufacturers that considers all the other components that has to be settled in the harness, and they design the final harness design. The results of which can then be checked for compliance with the standards, with the aim of automating this evaluation process in the future by analyzing the KBLBC data in all steps of the development. So finally, from the engineering point of view, all the time the engineers can be sure that the related products, processes, and designs comply with the standards. So why automation? Why do we need standardization? The goals of automation are reducing the production costs, ensuring product quality and quality documentation, implementing processes that are difficult to perform manually, reducing logistic costs, securing the supply chains, enabling rapid implementation for changes, and reducing inventory through manufacturing close to OEM plants. The recent situation and the latest events have shown us how critical and complex how long supply chains can be. I'm thinking of the Ukraine conflict and the current situation in the Middle East. So why standardization? Flexibility in face of the tactical changes. Everyone in the process chain works according to the same requirements and is able to check non-conformity immediately. Standardization is cost-saving. Standardization in component design enables economies of scale in production equipment. Faster implementation of automation system based on process standards. The development focus of the machines is not on developing variants and so on, but we can work on the process optimization because process is time and time is money less. Flexibility in production during volume changes is a significant point because automation requires significant investment. Inflexible automation has a high cost risk if products are phased out, volumes are reduced, or significant technical changes occur. So at a glance, we at SELS, under the umbrella of the ARENA 2036, automotive manufacturers, developers and producers of connectors, components, wiring harnesses and manufacturing technology have defined the fundamentals for automotive wiring harness production. This standard defines the requirements for the automation-ready design of components and wiring harnesses, as well as processing technology, and enables the assessment of compliance with the standard. In doing so, we are establishing the basis for high-quality, cost-effective manufacturing and decoupling our automotive industry from the risks of long supply chains. So thank you very much for your attention. And now, if I'm ready for some questions, or I hand over to the reports of the individual project teams.